Here we are in part 6 of the accumulating functions and fundamental theorem of calculus. We're taking a look at using the second fundamental theorem of calculus symbolically. And so we have this result from the second page of this packet, that the derivative of the integral from a to x of f of t dt is equal to f of x. So using that here should imply that that answer to this derivative question here will just be this function evaluated at x. So in other words, it should just be 3x squared minus 8x. But is it really that easy? Yeah, it is. Okay. Let's just run through the results just to show that it is. So we're integrating this function, which we should know that the integral of 3t squared is going to be t cubed, minus the integral of 8t would be 8t squared over 2, which is just 4t squared. And we're evaluating that from 1 to x, which means plug in x, I have x cubed minus 4x squared minus 1 cubed minus 4 times 1 squared. So that's what we get by integrating all of this inside. But what the problem tells us to do is it says now take the derivative of all of this. Well, this is a difference, so the derivative would just be the derivative of this minus the derivative of that. So let's see here. The derivative of x cubed is 3x squared minus the derivative of 4x squared is 8x minus, well, this is just all a constant, and the derivative of a constant is 0. So, yes, here, if this is an x, the derivative is just going to be this function evaluated at x. So for number 2, looks very difficult. We have a fourth root. We have an exponential function in it. But the derivative, as long as this is an x up here, from -2 to x, will just be the fourth root of x cubed plus e to the x minus 3x. Things become a little bit more difficult when it's not an x, but we have a function as that upper bound, or something we're doing to x. So let's just do what we did with example 1. We'll run through it, and hopefully we'll see that something works out nice and easy here. So again, working just the inside here, the integral of t cubed is t to the 4th over 4, plus the integral of t would be t squared over 2, minus the integral of 2 is 2t, and we're evaluating that from 0 to x to the 4th. So plug in x to the 4th, I get x to the 4th over 4, plus x to the 4th squared over 2, minus 2x to the 4th, minus, let's plug in 0, 0 to the 4th over 4, plus 0 squared over 2, minus 2 times 0. So let's go ahead and derive all of this. So let's see here. This is easier if we think of this as a 1/4 times all of this. So the derivative is going to be 1/4 times the derivative of this. This is a composition, so it would be 4 times x to the 4th cubed times the derivative of the inside, 4x cubed, plus 1/2 times 2x to the 4th to the 1st times the derivative of the inside, minus 8x cubed. Okay. Minus, again, all of this comes out to be 0. The derivative of that is going to be 0. So equals. Let's simplify here. 1/4 times 4 cancels. So I get an x to the 12th, or an x to the 4th cubed, times 4x cubed. The 1/2 and the 2 cancel. I get plus x to the 4th times 4x cubed minus, and I'm going to go ahead and back and rewrite this as 2 times 4x cubed. The reason being is this. We have here now a common factor, which I can take out, which leaves me an x to the 4th cubed plus x to the 4th minus 2. Now that's an awful lot of work, but take a look at what happens here. I end up getting this function evaluated at that upper bound. So this function is t cubed. I have here an x to the 4th cubed plus t, which is x to the 4th, minus 2. So I end up getting that function evaluated at x to the 4th. So it's x to the 4th cubed plus x to the 4th minus 2. This is just the derivative of x to the 4th. So when our upper bound is a function of x, because we are deriving, it is going to be the derivative evaluated at x to the 4th times, here's the chain rule, the derivative of that upper bound. So let's take a look at this one here and do it the same way, because I do not want to take the derivative of, or I don't want to integrate this, never mind then taking the derivative. So the first thing is we do have to switch. My upper bound needs to be the function of x. So we're going to write that as the derivative of the negative integral from 2 to 3x of sine of t over 4t minus 9 dt. So we get, well, first of all, again, with derivatives, that negative can pull through. We're going to evaluate this function at 3x. So it's sine of 3x over 4 times 3x minus 9 times the derivative of 3x, which is just 3. We can simplify this by writing negative 3 sine of 3x over 12x minus 9. So that's all there is for questions like this.